very nice event, the webinar, and for our introduction. Hi everybody who joined this webinar and have a willingness to learn something about the fiber optic interconnection and fiber optic sensing systems which SYLEX offer. The first few words about SYLEX is related to our history and our focus. So we are really a family-owned company, actually celebrating the 21st anniversary of our company. And since the beginning, we have been focused to the fiber optic. It's really a technological DNA of our company. We always focus to the fiber as a main part of any of our products. And this just logically led to the fact that we have two, let's say, legs on which the complete company stands. And this is the fiber optic interconnection products and the fiber optic based sensors using the FBG technology. The company itself is around 250 people with a revenue of 20 million euro a year. And we are worldwide present with our solutions. From my side, I will present and show you where everywhere we've learned during our present on the market that the fiber and the products from fiber are really used, sometimes really very curious. And later on, Peter will let you know more information about the fiber optic sensors. The best way how to show our activity are some real business cases. Our main areas are, as mentioned, interconnection and sensor and sensing systems. In case of interconnection, we follow and cover the requirements on the market as telecom, datacom, onboard optics, defense and mil application, even some local area networks and industry applications. In case of sensor and sensing systems, there is a civil structure monitoring like structural health monitoring, geotechnical applications, as well industry, because a lot of technologies require a special type of sensing, and offshore oil and gas, and also marine and subsea application. From the fiber optic interconnection, you can imagine that really data and calculating, it's an essential part. And we at SYLEX, I have to say that literally helped to discover the Higgs boson. This is the first real example where the products are used. You are probably familiar with some strange, let's say, abbreviation like CMS, ELIS, and ATLAS. And these are all the parts, the special experiments located in the largest world nuclear research institute in France and Switzerland. It's a CERN. For this special institute, we developed and manufactured on one side a very small, tiny connectivity system, which is based on the multi-fiber connectors. On the other side, all the data which are generated by this experiment should be transferred somewhere. And for this are required really a dedicated interconnection cables, harnesses, which are really special from the used connector type and length and cable design point of view. Another field where the products of the fiber-based materials are used are really everywhere around us nowadays. Also, this event can be and is possible to have only thanks to the fiber optic interconnection, which is a fiber to the home, fiber to the antenna, fiber to the building. And again, our capabilities to develop together with our partners this kind of solution were proven by the Belgian Telecom, where the complete structure is based on the solution which were manufactured, designed together with us. On the other side, complete world is connected with the submarine cables, which are really invisible for all of us. But these cables end on a coast, and the connectivity from the submarine to the local networks is realized, for example, by the products which we manufacture and design for Alcatel. The third area, which is as well around us, and we do not really see this, are the calculation, emulation, and the simulation. all the gadgets, all the smartphones, everything what we have are somehow designed, and the electronic design automation and supercomputing application is an essential part of this technology to be able on a very short time and very efficiently to design the chips used in these gadgets and electronic devices. And together with the really biggest players in the world, we again help to manufacture connectivity systems where a lot of times is used a very special type of interfaces. These are the multi-fiber connectivity connectors like MTP, MXC, lens-based systems, which are really very special compared to the standard single fiber products. Another area which is again surrounding us completely, and we do not realize this, is the data center world. Here, one of the examples is not only a data center used for collecting all the videos and tremendous data generated each day, but also in an application like medical industry, where again a company, Novartis in Switzerland, used our system to cross-connect and set up the data center, where not only the connectivity and storage of the data, but also the calculation and development of the new medicals were used. Here, some special type of connections like shuttle products, very dedicated different type of cables and connectors are again used to fulfill the customer requirement as regards the special connectivity, which is always somehow tailored. And last but not at least, the area where we are really active is the industry or the part of the world where the mission is really critical. It can be the space, medical, even some mill and defense harsh environment area, where we offer a solution based on the type of connectors, type of cables, and interfaces which are really dedicated for this type of products and environments, as lens-based systems, a special design termini, ferrules, and connectors for medical with a different size of fiber hole. So these are the basic. This is the basic overview of the connectivity, which is used, and this is an essential part and the backbone for any other systems that the data is generated, and this is also the part of the fiber break rating systems. So I'm now giving the word to my colleague Peter, who will tell you more about the fiber break rating systems and everything what is possible to measure with these kind of applications. Thank you very much for now.
Good morning, everyone. Thank you, Edward, for bringing us to the slides where the FBG technology and the applications will be presented. Maybe for those of you who are not very familiar with the technology itself, this is one slide that basically describes the background, how the technology works. So we're looking at the cross-section of a fiber with indicated location of an FBG, which is a fiber break rating located inside of the core of the fiber itself. And this features several possibilities to capture mechanical or temperature-induced changes in the fiber. And that is fully measurable, that is fully quantifiable. You can make very nice measurement results because this is very proven technology for many decades, we can say already. And what makes the difference in the world is not only the FBG fiber inside the fiber itself, but the difference makes also the transducing systems. That means the industrial sensors that we at SYLEX are focused on building around the fiber and making the FBG technology to be used in various applications. And we can have a look at some of those right now. The most typical application where at least SYLEX, but also many other players in the world have utilized the FBG technology is the civil structure structural health monitoring. The photos we are looking at, they are real projects that nowadays are still using our sensors and measurement technology. So I will just name some of those that we see here. These are really only examples. So we can see dams in Austria, we can see two bridges that are located in Bratislava in Slovakia. You can see our sensors that is called SC01, which is kind of unique sensor that combines strain measurement together with temperature compensation embedded in the body, and it can have a variable gauge length. That means your measurement base can not only be very tiny following the FBG length in the fiber, but it can be transduced to even a few meters length. That gives you several advantages over traditional technologies, because with longer gauge lengths you can capture little bit distributed or semi-distributed strain in your structure, and that has several advantages. So these projects are running for many years, and they have been used for either construction of the bridges, or they are used for a long-term monitoring of the performance of the bridge when it is in the use. On this next slide, we see another photos that are coming more to the ground side. So we can see open pit mine that is in Chile. We can see a sewer system that has something like arc type of sensors, and you can see that sensor types are shown in a bottom photos in this slide. These sensors have been developed particularly for this application, so they are easy to install. They are more or less, we can say, plug and play in a way, how you install it and how you connect it to the interrogator, and how you can retrieve the data from the structures. So why people are measuring these structures? It's very important structure when it comes to the integrity. So either you have having people or large object being moved through the tunnels. So we want to be really sure that these very expensive structures are not somehow compromised. So the long-term measurement based on FBG technology that has been proved with no drifts, with no being affected by electromagnetic fields, that has been very stable and providing very high sensitivity, is really a good choice for many of these applications. And we can see there also a pressure sensor down there that has been also used nowadays in measuring the water levels. Another typical application where the fiber optic and FBG sensors are used are also oil and gas industry, and we can see just a fraction of that industry here, showing pipelines that are transmitting gas or oil or CO2. So we can speak about hazardous or kind of explosive areas, again, where the fiber optic has by nature its perfect resistance against such environments, because you are not transferring any significant energy inside. There is no electricity, it's completely passive, and you don't have to be worried about how to install the sensors in these areas, and you basically don't need any specific and kind of extensive and expensive ATEX approvals. On these photos you can see again some few type of strain sensors. Some of them are temperature compensated. On the left top picture you can see cable connectivity that can be also made very easy, like plug and play, connector to connector. You don't need any specific splicing equipment on your side in most cases. Another area where the sensors are typically used, and we can call it a marine or subsea. And what we see on these photos is a marine pier that has been built in a sea, and has been later on backfilled with soil and concrete. So that's also another proof that when the design of the sensor is made robust enough, it can really withstand very harsh conditions. On the top left picture, what you see is a long monopile that can be really very long. It can be more than 1,200 tons heavy. And with your tiny fibers, you can make a very nice dynamic analysis of such structure while it is being hammered to the ground. And the hammering process is typical in an offshore area, because you want to have connected your oil platform or maybe a wind turbine to the ground. So you need to penetrate through the first layers of the ground, and these piles are then hammered to it to make a connection with the ground. So this hammering process is kind of dangerous to the pile. So if you are measuring it correctly during the process, you can be more or less 100% sure that the pile has enough capacity to carry on the weight that you want to plug to it. Another area where the FBG technology nowadays is entering is, of course, is a wind industry. You can have manufacturing processes control. You can make industrial instruments analysis and control. So there have been several projects and applications where this has been also implemented by our clients. We cannot share those details too much because that's kind of covered with the NDAs, but at least some photos that can show the areas where the clients are typically using these systems are shown here. So we can say that the FBG and the fibers are coming now almost everywhere. And when we say everywhere, we mean also that they are in Alps in Switzerland, so they are measuring the movement of the glacier, and this is also very important for the nature itself. And on the other side, coming from the mountains, there is also an installations of our sensor Subsea connected in a Caribbean area with a monobuoy. So we can really speak that the fibers are nerves of the earth, measuring and transmitting the data to our attention. Nothing would be possible without having good connection and being open with talking to a research and development and academic partners. And we are also creating OEM partnerships where we can utilize the capabilities of SYLEX. With 250 people, we can really manufacture high volumes. We can make unique designs according to the applications. And some of the pictures are showing here what it could be or what it could look like. And maybe the last slide, we are making this very quick now, and we would be very happy for your questions, or maybe if you follow up later on with us, because we have much more information about these projects. We can share our experiences with you with how to use the FBG technology in your projects. And in this last slide, we are just showing some other examples of what we have been working on during last year or two. So we have been also developing a special connectors, fiber optic that can withstand 150 Cs of Celsius. We have now in a testing a strain sensor that is capable to withstand 200 C as well. We have a dielectric strain and temperature sensor in case you need to go to areas where the steel is not possible to use. We can also define a rosette strain sensing, which is typically used for analysis of pipeline structures or other structures as well. We have made a very long-range displacement sensor with 30 or 40 centimeters. We have now gained also the experiences building up a marine-grade strain and temperature sensors that are located in the sea. And we have also been developing a special spot weld machine that has a very nicely limited energy, and it can be used like a control method of spot welding strain sensors even on pipelines transmitting oil, because the energy is very nicely controlled. So these are a few examples, and with this slide I would end up my presentation right now, and I'm happy to hear your questions. Thank you very much for your attention.